Hello, my name is Tom Holoien and I'm a graduate student in the astronomy department at The Ohio State University. I'm also a member of the All-Sky Automated Survey for Supernovae, or ASASS-SN, and today I'm going to be discussing one of our recent discoveries, which is presented in our paper, ASASS-15oi, a rapidly evolving luminous tidal disruption event. The ASASS-SN survey uses 8 14-centimeter telescopes located in Hawaii and Chile to scan the visible extragalactic sky roughly once every 3 days, looking for supernovae and other bright transients. Our transient detection pipeline was triggered on August 14, 2015, by a source located at a position consistent with the center of a nearby galaxy, about 215 megaparsecs away. We named the transient ASASS-SN-15oi and initially announced it as a candidate supernova. However, a classification spectrum showed that it was actually a better match to a helium-rich tidal disruption event, or TDE. There is little archival data available on the host galaxy, but an X-ray flux limit from ROSAT and infrared magnitudes from WISE indicate that it does not host any strong AGN activity. Due to the transient's spectral identification as a possible TDE, we began a multi-wavelength photometric and spectroscopic follow-up campaign using the Swift Space Telescope and multiple ground-based telescopes. These observations span roughly 3 months after the discovery of the transient. In the light curve of the transient shown here, data in different filters are shown in different colors, with colored stars indicating estimated host galaxy magnitudes in the same filters. The light curve shows that the transient was much brighter in the UV and bluer wavelengths than the host, but that it faded rapidly, unlike what is seen in other TDE candidates. While we do detect X-ray emission, it is below the flux limit from ROSAT and may not be associated with the TDE. Early follow-up spectra showed a strong blue continuum and broad helium emission features, but these features faded rapidly, with later spectra showing little evidence of the transient. This rapid fading is in contrast to other TDEs, such as ASASS-SN-15oi and ASASS-SN-15li, which showed spectroscopic emission features for many months after discovery. However, a spectroscopic comparison between ASASS-SN-15oi, the helium-rich TDE PS1-10JH, and 2 supernovae of the types most likely to produce the observed emission features show that ASASS-SN-15oi is very unlikely to be a supernova. Both the Type 1b supernova SN2004GQ and the broadline Type 1c supernova SN2002AP show absorption features and continuum levels that are not present in the spectra of ASASS-SN-15oi, while PS1-10JH is very similar. We modeled the transient's luminosity and temperature evolution by fitting blackbody curves to the observed SED. These fits were made with a strong temperature prior, as the peak of the emission is bluer than our bluest UV filter. Unlike as was the case with previous TDEs, the fits indicate that ASASS-SN-15oi was increasing in temperature over time, from a starting temperature of about 20,000 Kelvin to roughly 60,000 Kelvin in later epochs. The luminosity of the object, shown here, drops steadily at a rate that is best fit by an exponential decline. The X-ray luminosity, shown as red triangles, remains roughly constant, though again this emission may not be related to the TDE, and it is roughly 2 orders of magnitude less luminous than the optical and UV emission. Integrating the luminosity gives a total energy of about 5 times 10 to the 50 ergs released by ASASS-SN-15oi during this time. Now that ASASS-SN has discovered 3 nearby TDEs which have all been heavily observed from the X-rays to the IR, we were able to compare and contrast their properties. Such an analysis was not possible with previous TDE candidates because they are fainter or do not have the same high-quality datasets that ours do. Here we show the luminosity evolution inferred from the UV and optical blackbody SED fits. ASASS-SN-15oi is clearly more luminous than the other 2 ASASS-SN TDEs, and its luminosity falls at a rate comparable to that of ASASS-SN-14AE. Integrating these curves, the 3 TDEs radiated a similar amount of energy during their flares, requiring only a few thousandths of a solar mass of material to have been accreted. This suggests that either TDEs accrete very inefficiently, or that only a small fraction of the disrupted star's mass is accreted. ASASS-SN-15oi clearly stands out from the other 2 in its blackbody temperature evolution. While the other 2 ASASS-SN TDEs remain at roughly constant temperature throughout the duration of the flare, ASASS-SN-15oi becomes much hotter in only 70 days. While there is systematic uncertainty in these temperature fits, it is clear that ASASS-SN-15oi is increasing in temperature while ASASS-SN-14AE and ASASS-SN-14li are not. The photospheric radius of ASASS-SN-15oi also evolves much more rapidly than those of the other 2 ASASS-SN TDEs, although all three exhibit the receding photospheres necessary to maintain a luminosity decline despite constant or increasing temperature. ASASSN-15oi becomes the most compact of the three objects after only about 70 days. ASASSN-15oi is the third bright nearby TDE discovered by ASASSN in only a year and a half of full operation. Like ASASSN-14AE and ASASSN-14Li, ASASSN-15oi is one of the best observed TDEs ever discovered, and it seems to have an atypically high luminosity and an atypically rapid evolution. All three of the ASASSN TDE candidates are unique in some ways, and by discovering more of these objects in the local universe, ASASSN will be able to build a catalog of bright, well-studied TDEs, which will be necessary for fully understanding the physics behind the emission that we see from this interesting class of objects. For more information on this work, please see our paper which is posted on the archive. Thank you.